Hello, everyone. My name is Chun-Wei, and I'm a PhD student at Purdue University. I work with Zhuoyan and my advisor, Dr. Ming, for this work. Today, I will present our work on behalf of my co-authors. Have you ever heard of the old saying that two heads are better than one? This old saying highlights the value of collaborations and the power of collective thinking. Indeed, discussions among a group of people can often bring together diverse perspectives, ideas, and experience to make better decisions. But are two heads still better than one in AI-assisted decision-making settings? Today, I would like to share our finding about the difference in the behavior and the performance of groups and individuals in human-AI collaboration. Every day, we are faced with decisions that can significantly impact our lives and those around us. Artificial intelligence is increasingly being used to assist people in making decisions in various domains, ranging from finance, healthcare, education, and criminal justice. In these AI-assisted decision-making settings, AI models often make predictions while people can decide whether to follow or overturn the recommended decisions. Previous research has explored the effectiveness of the collaborations between humans and AI in decision-making from multiple aspects, such as decision accuracies, humans' reliance on AI, fairness in decision-making, decision competence, accountability, and humans' understanding of AI. Most of the existing research focuses on how individuals collaborate with AI in decision-making. However, in reality, many decisions are made by a group of people instead of individuals. Using criminal justice as an example, many countries have adopted jury systems. A jury is a group of people selected to hear evidence and arguments presented in a court case and then decide on a verdict. Since group decisions making is often not a simple aggregation of individuals' decisions, it is still unclear whether the finding for individual AI collaborations can be generalized to how groups interact with AI assistants. Therefore, our research aims to explore how groups and individuals differ in their performance and behavior in AI-assisted decision-making. We evaluate the difference from the 6 aspects we mentioned previously. To answer these questions, we designed and conducted a sequence of human subject experiments in the domain of recidivism risk assessment. In each task, we gave participants a defendant information, such as their race, gender, and criminal history. Then, we asked our participants to predict whether a given defendant would reoffend within 2 years with the help of the COMPASS model. COMPASS is a risk assessment tool used in the criminal justice systems to predict the likelihood of defendant reoffending. It was found that COMPASS is biased against certain groups, such as people of color, and it can lead to unfair and discriminatory outcomes. By adopting COMPASS as the AI assistant in our experiment, we could better understand how humans use biased AI assistants in a group versus individually. In our experiment, we had 2 treatments. The first treatment is individual AI treatments. In particular, in this treatment, we asked participants to make the recidivism prediction based on the defendant information and the COMPASS predictions without any input from others. The second treatment is group AI treatment. For this treatment, we provided a real-time chat room for the participants. The participants had to discuss with other team members and reach a consensus on the final recidivism predictions. In our experiment, we assigned at most 3 members to one group. Our experiment could be separated into 4 parts. The first part aims to understand participants' own cognitive style in making recidivism risk predictions. In particular, in this study, a participant's cognition style was categorized by how their predictions are influenced by the defendant's race and charge degree. On these tasks, We did not provide receiver risk prediction made by Compass to the participants. And we also did not reveal the ground truth answer to participants in terms of whether the defendant actually reoffended with 2 years or not. The next 3 parts happens on few days after the first parts. The second part aims to have participants try out Compass and learn about its strengths and weakness. Hence, we provided the Compass predictions to participants for them to judge the residual risk before they made their decision. After they made the decision, we also displayed the ground truth to participants so that they can tell when Compass was likely to be right or wrong. In the formal test session, we randomly assigned the participants into 2 treatments, and we recorded their final prediction in each test to help us evaluate their decision accuracy, their decision on the AI recommendation in terms of whether their final prediction agreed with AI, and the fairness of their prediction. At the end of each task, we asked the participants about their confidence in the final prediction. After complete the formal task, in an X survey, we asked participants additional questions to evaluate their understanding of the Compass model and how they would assign the credit of making correct predictions or responsibility of making the wrong predictions among themselves, AI, and possible their teammates. Based on the data we collected from our experiment, we found that there are no significant difference in the decision accuracies and the understanding of AI between the 2 treatments. In today's talk, we focus on discussing the difference we found between individuals and groups in their reliance on AI, decision fairness, and decision confidence. First, we found that the participants who made decisions in groups rely on the AI model more than the participants who made decisions individually. In fact, this is true regardless of the correctness of the AI prediction. In terms of decision fairness, we found that the individual predictions on Black defendants appears to have much lower accuracies than on white defendants. But the prediction from participants who made decisions in groups have a similar accuracies on Black and white defendant. In other words, group decision makers provide fairer decision accuracy than individual decision makers. In terms of decision confidence, we noticed that when group decision makers challenge the incorrect AI prediction, they will be more confident than individual decision makers. Our experiment also enabled us to identify a few interesting patterns in how the presence of AI model impact group dynamic in AI-assisted group decision-making. We found that participants in groups sometimes start their conversations with others by quoting the AI model's predictions. They will also use AI predictions to support their viewpoint in order to convince other group members. When the group could not make consensus, participants may also use AI predictions as the tiebreaker. But sometimes group takes the AI prediction into account in a more critical way. For example, sometimes the discussion among participants focusing on trying to justify the AI prediction or to trying to argue for why the AI prediction could be wrong if they have a strong counter arguments. Moreover, participants would even explicitly analyze the trustworthiness of the AI model to decide whether they should follow the AI prediction or not. To summarize, here are some key findings from our experiment. In general, our experiment and results highlight that people in groups interact with AI assistants in a different way than how individuals interact with AI assistants. Our paper contains more results about the difference between groups AI and individual AI from accountability aspects. Moreover, we also explore how group diversity influences group AI interaction. Thank you again. If you have any question, feel free to ask us.